Okay? So, we're going to do a couple problems here where we're going to be working with these forms. So writing a slope-intercept form, I would say simply this. You have to know where it starts at because that's the y-intercept. And you need to know where it's going from there, and that's the slope. If you have that together, you got y equals mx plus b, start, and slope. All right, so the cost to rent the power washer was an initial charge of $25, and from there it's $5 per hour of use. Write an equation that best represents the cost based on hours of use. Okay, very simplistic little linear equation. I'm going to say C stands for the cost, and I want to know what it equals. Is there a starting point? And there is. They actually say it. The initial charge of $25. From there, you see it goes up $5 per hour. If you see the word per, essentially that's a rate. And that's telling you how it's changing. So we have the initial cost of $25, and then from there it's going up $5 an hour. That is the slope. So when I say take it to letters, we would say, you know what, there's a starting point of $25, and then from there it's $5 per hour. Okay? You can rewrite that with this term in front of this one. It doesn't matter, but there would be your equation. Okay, let's try another one of those. Sandra had 200 friends on her Facebook page and is averaging an additional 4 friends per week. Write an equation for her number of friends based on weeks. So now we're not talking about the cost of a power washer. We're talking about Sandra's friends. Good. Give me a letter. I hope you said F. And now we can make an equation for this. Is there a starting point for Sandra? And the answer is 200. 200 friends. From there, it's going up. There's your slope. See the word per. 4 every week. And this would be an equation for how many friends she'd have in an unknown amount of weeks. Okay? So again, slope-intercept form requires a starting point and where you're going from there. And it's not too complex. All right, we'll try one more. Dan figured there were 3,000 square feet of surface area on the barn to paint. He's painting a barn. Okay? You don't have to do this, but you can make a drawing of that. He's got 3,000 square feet to start with to paint, and he starts to paint it. And he can paint 20 square feet a minute. That's pretty impressive if you think about that. He must have one of them power spray painters. Write an equation for the number of square feet remaining to be painted after M minutes. So now we're talking about how many square feet is left to be painted. So I'll use S for square feet. And what is the starting point? Okay, 3,000 square feet is the starting point. He's painting away. So if we start at 3,000, his painting, it's going down because he's painting the square feet. And it's going down 20 feet every minute. So if we take it to letters, we have going down 20 per minute. They may ask you, what's the slope? Well, the slope is the thing that's multiplying the independent variable. The slope is negative 20. What does it mean? It means he's reducing how many square feet to be painted by 20 every minute. Okay, what is the 3,000? Well, that's the starting point. So you can see these slope-intercept questions. They can be asking you for equations, and then they can be asking you what do these values stand for. Okay, very important. Okay, it looks like that's it. That's the third video on equations, linear equations, and today's was slope-intercept form and standard form. Good luck to all you juniors.